Welcome to Biota Live. I'm Tom Barbalet, and this is being recorded live on TalkShoe, July 16th, 2010. Biota Live is a continuation of the Biota podcasts. For more information on the Biota podcasts, check out biota.org/podcast. And we have a bit of news and notes. It's been about a month since we last recorded a Biota Live. We have Steve Grand on the line. Hello, Steve.
Hey, Tom. Can you hear me?
Oh, yes. Yes, very well.
Hey.
How's it going?
Works. Good, thank you. How are you?
Oh, pretty good, pretty good. I've just gotten back from the Bay Area.
Yeah, how were your talks?
It was, they were pretty good. I put the first one in the Biota feed just yesterday.
Yeah, I listened to part of it today.
Oh, terrific, terrific. And
good.
just before I did the talks, or just before I did the SRI talk, I spent an afternoon with Jeffrey Ventrella, which was a real luxury.
Uh-huh.
Have you met Jeffrey?
Briefly, once, quite a long time ago, at a conference in Los Angeles somewhere.
Oh, okay. Was it one of the ALAS conferences?
Yeah, that's what it was. At UCL, or, yeah, 98, that's what it'll be.
Right.
Yeah, but we only met for a few minutes.
Yes, I think that's probably the nature of some of those conferences. Yeah. The only real bit of news and notes actually relates to the Grey Thumb groups. I had a chat with Adam Eremenko a couple of weeks ago about what is happening with the Grey Thumb chapters. Folks who are familiar with the Grey Thumb blog will have noticed that it's been down pretty well since the start of this year. And I'm pleased to announce that Biota is going to be hosting the Grey Thumb blog, or at least the historical account of the Grey Thumb blog. And news for the Grey Thumb chapters, I spoke at SRI at the first Bay Area A-Life meetup, and I think the plan is that all the Grey Thumb chapters will form independent artificial life groups, which I'll continue to promote through Biota Live, but I think the Grey Thumb Central in Boston was just getting a little overwhelmed with the new chapters. So the plan is now to form independent grassroots artificial life groups and take it from there. Well, Steve, the reason I had you on this evening was to talk about Simergy. But as you've heard part of the talk at SRI, what was your general sense? Did you get to the part about the artificial life community, or how much did you listen to?
No, I listened to all the stuff about, or some of the stuff about Noble 8, but I didn't realize you had talked about the community.
Yes, towards the end, I got to that point, and in large part inspired by spending an afternoon with Jeffrey Ventrella talking about various aspects of the community, and certainly you're providing inspiration to him currently. He has a vision with regards to gene pool in terms of releasing, I think, a good component, if not all of it, open source.
Yeah.
He's certainly watching the developments of Simergy with some interest.
Well, that's funny, because I'd probably be watching Gene Pool with some interest for the same reason.
Yes,
I thought that already was open source. I thought you'd started that together.
We released another one of his projects called Melody Ball, and we talked a little bit about Melody Ball when we were in Menlo Park just before the SRI talk. But no, he hasn't actually released it open source yet. It's free to download. But I think certainly a few people have expressed interest about incorporating aspects of gene pool in their various simulations. And we talked a bit about cross-platform development in terms of Windows, Mac, and iPad. And iPad and Mac are actually different, or I guess could be considered different platforms. In particular, how one kind of layers the languages, because obviously the iPad and the Mac now are Objective-C Cocoa interfaces, and certainly if you programmed in C++. Although, interestingly enough, I was at Apple just before I met with Jeffrey. He picked me up from Apple. Actually, I was talking to my open source manager friend at Apple, and he was saying that a number of the Mono, which is the C# version on Linux, a number of the Mono interfaces are also compatible with Objective-C. I'm not sure how they're actually doing that, but it may make a Mac version of Simergy a little bit easier.
Well, that would be good. I had a feeling Mono was available for iPad and an iPhone anyway, wasn't it?
I think so. Yeah.
Yeah, certainly a mono version would be very, very much easier because you'd only have the 3D stuff to change, and that has to be changed anyway.
Certainly. Well, they were very excited about the Unity graphics engine, which I think appears visually very similar to what you were trying to do with XNA, I guess. We'll go through point by point with regards to Simergy, but certainly I think there's potential for all these kind of things to be translated through similar XNA-like interfaces.
Yeah, funnily enough, I'm using Unity now for my new game.
Ah!
and it's very nice too.
Yes.
Yeah, I'm really impressed with it.
Very good.
But I even parted with $1,200 to get the pro version.
Yeah, no, I downloaded the free version based on the recommendations of my friend at Apple. And certainly, yes, was very impressed. I'm not sure how things are going to fit together with Noble Ape, but the big announcement with regards to Bob Mottram's changes, of course, another mutual friend of ours, is the Noble Ape web server, which I think will probably make a Unity-like interface relatively trivial in terms of the driving of it through some XML interface. It's wonderful to be working with Bob, actually. How were you connected with Bob in the past?
I have no idea. I really can't remember. We got to know each other via robotics rather than A-Live.
Certainly.
And it was way back when I was building Lucy, or maybe when I'd finished building Lucy Mark 1.
Right.
But I honestly can't remember. But we were both in England at the time, and I don't think we've ever met in real life.
Okay.
Just one of these email meetings, you know.
Certainly. Yeah, I don't want to speak for Bob, but I don't get the impression he gets out of North Yorkshire very much, and he lives in a very beautiful part of the world. So I don't understand why one would stay remote in that kind of environment. Do you know? I gave a bit of a rap with regards to his robotic vision stuff, but do you know much about that?
I can't remember much about it. We used to have long email discussions about vision and AI in general many years ago.
Gosh.
Yeah. So we go back quite a way now, I guess.
Yeah.
98, something like that.
Gosh.
But only ever online, and now we're both Facebook friends, so I kind of keep track of what's going on that way.
Yeah. Did you get up to the section of the talk where I started detailing Bob's changes? No,
I didn't.
Oh gosh. Okay. Well, you've got some interesting listening to come, because he certainly ripped apart the Noble Ape simulation and moved it in a number of quite exciting different directions, including the web server, but also this notion of Apebook, which is really, I guess, the Noble Ape social graph. So it's kind of social network for Noble Apes, but it also fits into the kind of narrative history. Some amazing stuff coming from Bob. I mean, he's just a phenomenal developer, and his ability to take articles online and then take the Noble Ape in the particular directions of the articles has been phenomenal. So yeah, hats off to him. It's wonderful to have him as a mutual friend, as is Jeffrey Ventrella. Like I said, we spent the better part of a day actually wandering through sections of Palo Alto and Menlo Park, talking about various ideas and various mutual friends and experiences. And I think certainly the stuff Jeffrey's talking about in terms of self-publishing and mathematics and these kind of things, very much the inspiration of mathematics in terms of probably even creating a new generation of simulators that are interested in playing with mathematics as you and I and various others in the community have in the past. And the idea of writing in this regard, I talked last time he was on about his prime number book, which he is completely reworking and apparently has doubled the text and size. Have you heard about that book at all?
No, I haven't. No.
It's to do with the spacing between the composite space and prime numbers and various underlying patterns that can make very interesting simulation properties. And it actually reminds me very much of some of the early Noble Ape development, which I used for similar spacing in, I think, sinusoidal rotation or something like that. But we had a long talk about Newtonian spatial mathematics and how it could impact understanding of numbers and various other things. So I think I'll probably send him my copy of the first edition, which I've gone through quite heavily and written a lot of notes in the margins of. Yeah.
I'm a mathematical numbskull.
Well, I think Jeffrey approaches mathematics. I mean, he's not a mathematician either, but he approaches it very much as math as art. And I think that's really the way most of us embrace it for our own particular simulations, and certainly reading the Creatures papers associated with the chemistry, there was a good deal of underlying mathematics as art through that stuff as well. So,
well, I feel much better if you call that mathematics. I can understand that. but I had to struggle to cope with matrix math and vector math for 3D stuff.
Certainly. But no, it was wonderful spending an afternoon with Jeffrey, and I think it really. I know Dick Gordon came through and visited you on a couple of occasions, either last year or earlier this year, and it's really wonderful to be able to actually spend a bit of time with people in the community and kind of rap about a wide variety of subjects.
Yeah, I've been out of touch for too long. It was nice to talk to Dick. It was good. We had a good day together when he came down.
Yes. Well, like I said at the end of the SRI talk, that's the first public talk I've given in the past 10 years. So I certainly embrace the idea of the hermit. Although, having said that, it was wonderful to meet a wide variety of people while I was in the Bay Area. And certainly the questions that came out at the end of the SRI talk, I mean, I think it's an hour and 15 minutes of talk and then 45 minutes worth of hard questions, including how one actually survives and maintains artificial life simulations. So I think probably the trick was after 3 days of very limited sleep, you could get pretty honest answers out of me. It was relatively late at night too. I think that the whole thing finished about 10:30 in the evening. So,
oh wow.
Yes. But anyway, let's. The reason I wanted to invite you on, aside from just the ability to have a wonderful chat, was to talk a little bit about Simergy. And I understand one of the rules of Simergy is that Steve Grant will not talk about Simergy.
The rule is Steve Grant won't get his hands dirty with it anymore.
Exactly. But certainly, I mean, since its release, and I sent it out on a few artificial life forums, including Artificial Life Announce, which then kind of propagate in a wide variety of different directions, there has been some interest in it. And as I understand, you will occasionally talk about it. I wanted to have the opportunity just to chat with you this evening for folks who are actually coming to it, who are starting to tinker with it, who may have downloaded the source code off the SourceForge Subversion repository, and are starting to look through the directories and starting to wonder, firstly, what more is there to be done, what things are missing, but probably to start off with just a kind of overview of the directory structure and, the nuts and the bolts of it.
Do you expect me to remember?
Well, I can literally read the directory structure to you and then...
Well, no, I can see the project. I have the project open in front of me.
Very good.
Although I can't actually compile it, unfortunately. So I've moved on because it was written in Visual Studio in 2005, and with Managed DirectX 9 point whatever. And I don't have either of those on this machine, but I can at least see the code.
Okay.
Okay. Well, shall I talk a little bit, give a bit of an overview of what the logic is, what the point of the software is first?
Terrific.
And then that will probably remind me how the actual code works.
That sounds like a plan.
It's first of all, you have to forgive me if I call it symbiosis, because I haven't got used to the idea of it being called Simergy.
Yes, unfortunately, I mean, for folks listening in, there were so many projects with the SIM spelling of symbiosis that I think it's probably something that's formed part of the collective unconscious of some broader open source community. So Simergy, however, had not yet been taken, so I snapped up that one and released it under Simergy.
It's a good name too. I like it.
Very good.
There's been symbiosis for 30 years now, so so I kind of get used to it because the idea goes back to 1979.
Would you want to talk a little bit about the history before you actually get into the project itself? Yeah,
sure. It probably helps to get across what I was trying to achieve, and then therefore why I've done it the way I've done it. Yeah, so think yourself back to 1979 when computers had 1K of memory and no assembler, no compiler, and you did everything in hex. You remember those days?
Certainly.
Because I came to computing through electronics, and so I was used to the idea of building circuits out of building blocks, and so I came to biology the same way, and I thought of an organism as being a bunch of building block cell types plugged together into circuits, and it was the circuitry that defined the overall behavior of the system. So I had this vision come to me like in a dream kind of thing back in 1979 of little grids, movable grids. Imagine floating grids onto which cells could be fastened, and so the cells were connected to each other on several sides, and
almost
they would
like those breadboard soldering things.
Yeah, that was the kind of thing I had in mind. There used to be a kid's electronics kit that had little cubes with magnets in, and there was a transistor or a resistor or capacitor in each cube, and you could plug them together on a board. So that was the kind of thing I had in mind, and so I was thinking that it would be cool to have various kinds of sensory cells that emit a signal when something happens in the outside world, and various kinds of actuator cells that do something to the outside world when they receive a signal, and then various kinds of computational cell that could go in between. And I was interested in trying to find out some basic building blocks of biology that we could use to build organisms like that. And I had this vision of these grids of cells floating around and eating each other and having sex with each other, and reproducing, giving birth to new ones, with genetics and so on. But in '79, I couldn't actually code any of that because my computer didn't have any graphics and it was too small, and I had to program in hex. So the nearest I got back then was probably in 1980. I built a plant simulator based on the same kind of grid model, and used it to evolve carnivorous plants. So you plug together, the genes would plug together some basic cell types like stinging cells and digestive cells and stuff, and then the software would fly some little flies across the screen, and if they hit a stinging cell, they'd fall, and if they landed on a digestive cell, the plant would gain energy, and so the system evolved and so on, which was fun, and I learned a lot about evolution, but that was about the limits of my programming ability back then. So the project went quiet until 2001, when the British Council came to me and asked for something that we could do to showcase British AI, and so I revisited the project, but in this time to do it in hardware. And so I spent a few months building these cells in real life with a little microcontroller in each module, and modules are plugged together, and you could build simple little creatures that could move around and sense their environment and stuff using these cells, and that was really, really cool. I'd love to finish that off sometime, but unfortunately my contact at the British Council left and the project kind of died a death. But the basic principle was in place then, which was that you could build creatures from these cells just by plugging them together. No grid, just they'd all have plugs and sockets on them, and you plug the plugs into the sockets and build these structures, and it would be the morphology that dictated the function. Form follows function, but then casting around for something to do in about 2004, that's when I started writing a virtual version, now that 3D was good enough, and that's where we are now. That's the software that's now on SourceForge. So the architecture of the game, I mean, from the user's perspective, the 3D game, it's based underwater, because I figured that the underwater life is pretty interesting, and particularly very simple underwater life, plankton-like stuff,
It's also beautifully three-dimensional as well in terms of its movement space and ability to propel in various directions and these kinds of things.
Yeah, exactly. And you automatically get sort of 4 habitats. You've got benthic creatures and creatures that float in the middle and creatures that float under the surface and creatures that swim on the surface. So you get some various habitats without actually having to build any complexity into the environment. And it's kind of graceful as well. So I made the environment the sea, and there's a submarine, a little yellow submarine that you drive around in, and that's where you go and actually fly around and watch your creatures and track them and see how they behave and do all that kind of ecological side of things. But you actually build them there's a research vessel, a big ship, and the ship's got a hole in the middle, and in that hole is a laboratory, and so the user's view is looking into a video screen into this hole, and around the video screen are knobs and buttons and switches and things that you use to control the design. And then there's a kind of pin thing in the middle. I've forgotten what I called it now, but that's the tool that you build your creature on. You can rotate this around, so you can look at your creature from various angles and stuff, and you add cells to the pin until you build up your creature, and then you let it go, and it floats down through the bottom of the ship and hopefully does something useful. And there's a tractor beam so that you can get it back again for debugging it. So the creatures themselves are they're made from cells. There's no kind of parent or anything. You just start with a root cell and then build onto it. So each cell has one plug and 0 or more sockets, and you can plug the plugs of one cell into the sockets of another cell. So that means that the creatures you build are essentially a tree structure. You start with a central cell and then build outwards to form a tree. And each cell is just like originally envisaged. It's either a sensor or an actuator or some kind of computational unit that goes in between. But I was kind of faced with a problem then, because we can build the morphology of the creature by plugging the cells to make this tree structure. Trees are obviously the best way to handle complex composites in 3D. But in order to make the circuitry work, I needed more fluid kinds of circuit structure than just tree structures. You needed to be able to send signals past one cell and to the next one cell along, if you see what I mean, and things like that to make any kind of circuit. So I spent months trying various ways of doing this, and the system I eventually settled on is that each plug or socket is the entry or exit point for one or more channels, and the channel carries a chemical. And so there are input channels that go to the internal structure of the cell and drive whatever inputs that cell might have. So if it's a muscle cell, say, that twitches when you supply a signal, the signal you supply is through one of these channels. But there might be other control channels that allow you to control how much the muscle will flex, what the limits of its movement are, and that kind of thing. And then there are output channels that come from sensors and the like, that send signals in the other direction, and bypass channels that go in as a plug and come out at one of the sockets. And so those are the way that you can send signals past one cell and into a cell further downstream. And then to define how these things wire up, you just specify which chemicals they carry. So if you've got say a light sensor with one output channel that produces a signal according to how much light there is, and you connect it to a muscle cell that's got two input channels, one controlling the range of the muscle, one controlling the force, then if you make the light sensor's output channel produce a red chemical and the muscle force input be a red chemical, then that specifies that the output from the light sensor goes straight into the force input of the muscle, rather than to the other channel. So you wire the thing up by changing the chemistry, by specifying which chemicals go through which channels, what their specificity is. And as far as I can see, that allows you, at least in principle, to wire up any arbitrary circuit, even though the physical structure of the creature is a tree. Does that make sense so far?
Certainly. In fact, I'm reading the code as you're describing it, which is adding more to what you're talking about too.
I should be reading it as well.
Well, no, continue.
So that's the basic structure. All cells are derived from the same class, and the submarine and the ship and that kind of thing, they're also organisms. They're also collections of cells. And the code is designed in such a way that you can add on new cell types after compilation. So you can just drop a DLL into the folder and some graphics to go with it, and the new cell types will become available to the virtual world. So that was a kind of driving force behind the design of the code, this ability to drag and drop new things into the code. Luckily, C# and .NET make that really easy. So when you look at the project structure of the thing, most of it comes in the Symbiosis project, which obviously defines most of the stuff. But then there are other projects, each of which define various cell types, and they're all derived from the same superclass, cell class. And so you can code up another of these projects after the system's been compiled, and just send someone the DLL, and they can drop it into their game, and those cells will become available. There was some fiddling about that had to be involved in terms of how these different DLLs can access code in each other, and so there are some interfaces declared that open up some of the stuff that's available in the main project to make it available to these DLLs, which may be a bit ugly. There may be better ways to do all that, but basically it works. And I was able to make a bunch of cell types and plug them together and get them to work and make some creatures that did things. But then I gave up on the project. And so what's waiting to be done in terms of the main core code is mostly new cell types. I want as many cell types as possible. I just did a few of the necessary ones for things like the cameras and the submarine and that kind of thing, and some simple oscillator cells and signal modifying cells and various kinds of sensors. But I kind of got to the fun bit, and then I actually stopped the project. And so the fun bit is left to go, which is thinking up interesting and ingenious new kinds of biology and coding them up as cell types.
And in terms of reproduction, is there a possibility of creating what's the terminology that you're using for these cell tree creatures? Is there a particular name for them?
For the creatures themselves? No.
Okay.
No, they're just organisms, and they come under class organism.
Okay, so these organisms, as they are released from the mothership and left to swim around, is there potential for reproduction amongst them to create new classes of creatures and new through building new cells.
Yep, there is. The structure of the creature, so the tree structure, the hierarchy, and the allocation of chemicals is defined in XML. And so each creature carries with it a genome. And I can't remember how far I got with sex, actually.
Right.
But certainly you can create a new creature from a genome, and it will be a simple matter to do the equivalent of crossing over to combine two genomes, because they're just tree structures in XML, to make a new creature that's the offspring of both parents. And there's scope for all sorts of ingenuity when it comes to sex, because the creatures basically just squirt these XML files at each other to produce a new offspring, but somehow or other you've got to make sure the creatures can get together and recognize their own species and couple and mate, and all the code's in there for that. Well, pretty much all of the code's in there for that, but it needs some cell types and some ingenuity in terms of biology for how you can create cell types that would enable a creature to recognize its mate and navigate towards it and swap DNA.
And I guess methodologically, the question that many might pose is the distinction between the DLLs, the XML, and whether this could actually be replicated by, I guess, a large-scale scripting engine or something like that, where the DLL components are actually represented in some nutritious script, potentially Lua or Python or something like that.
I think that would be pretty easy to do. The interface, basic class declarations for cells is fairly straightforward. There's a relatively small number of functions that you have to overload, update functions and that kind of thing. And so it doesn't take very much code, maybe a dozen lines on an average cell to declare a cell type and put its specialized code in place. Now, I chose to do that with C# because C# can be compiled at runtime and it's a nice, easy language, and all the rest of the code's written in C#. But there's no reason why you shouldn't use Python or anything else. So I imagine it'd be quite easy to insert that and make cell types that could be declared and defined at runtime. Don't even necessarily need DLLs.
And in terms of the physics and of the simulation, is there actually a water surface, or is it kind of infinite water in all directions?
The bottom of the ocean rises up to become mountains, and that's what defines the edges of the sea. So the landscape is actually a grid. In 3D terms, it's a quad tree. So working out which objects can possibly interact with each other and which ones appear on camera and so on is done by a quad tree. So there's the world is one rectangle, which is made of four smaller rectangles, made of four smaller rectangles, made of four smaller rectangles.
Yes.
So that's the extent of the world. But I brought the bottom of the ocean up above the surface at the edges, just to delineate it. But you can't do anything on the land. I haven't got any physics in for above water behavior. The physics stuff is a pile of crap. I didn't have physics, the actual ready-made physics engine available at the time, so I rolled my own. And underwater stuff is a bit odd anyway.
Certainly.
Plus, I had the biggest constraint in this game is the vast amount of computation going on, because each creature might be made of anywhere between maybe 10 and 100 cells, and you might have dozens or hundreds of creatures, and they've all got to be executed all the time. They can't switch off when they're off camera. So there's a lot of computation going on. So I had to try and cheat as much as possible with the physics. and yet still have physics that was real, in the sense that if you designed a cell that flapped, it would push the water in the right way and produce propulsion. So my attempt at a physics engine is pretty pathetic, and could do with a lot of work. Particularly collision detection is not good. So that's an area of the code that could do with kind of gutting and starting again. And you could probably use physics. I don't know how to pronounce that. PHYSX.
Yes.
The commercial physics engine.
Yeah.
You could probably use that now. That's what Unity uses, and it seems to work pretty well. Certainly.
In fact, that was the point I was going to make, that if you're using something like Unity for the graphics, you would get that for free, in inverted commas, although not
yeah.
quite. But I think what interests me is the ability with new cells to also, if you had physics that included land and even potentially air, there could be almost like flying fish or these kind of things that could then move into land creatures or birds, or a wide variety of other possibilities. And certainly I got the sense without looking through the code that really you started, as you say, because of the computational reasons, but increasingly now these kind of things, be they games or simulations, are oftentimes run over distributed networks as well, and the way that you've designed the spatial partitioning could lend itself very easily to multiple systems running multiple parts and kind of either exchanging creatures or exchanging camera angles or sharing the processing in some way, which would be relatively easily done through spatial quantization or other possible methods.
Yeah, you could do it peer-to-peer probably.
Certainly. So I think from my perspective, looking through the code, it was the degree of potential for external folk that have interest in this regard to come to a simulation which is relatively mature, also has obviously this rich game interface, and take it in a wide variety of directions. Projecting into the future, in terms of coming back and seeing this in maybe a year or 2 years' time, what kind of features would you like to see added by the open source community?
Well, aside from making the graphics work, because managed Direct 3D is now defunct, and getting the physics working, I think cell types. That's where the interest comes in, is in coming up with cell types that are elegant. You could, in principle, have thousands of different cell types, each of which does something very specialized, and it would be like an Airfix model. Do you have Airfix models over here? Where there's only really one way to build it. But what I was hoping for was something closer to Legos, where you've got a relatively small number of building blocks, but there are many ways to put them together to do interesting and ingenious things. So that's where the elegance comes in, is in thinking up new cell types. And I'd love to see a good variety of those. But like you say, being able to move above the surface of the water and onto land and into the air would be great too.
So in terms of people coming to this, I guess there's been a relatively harsh distinction between C# based open source and non-C#, and this was really my question with regards to scripting and embracing general ideas. I think certainly looking through the source code, it would be relatively easy to port sections to a language of choice or even to a scripting language. And I think looking at some of the stuff that's coming out in terms of web server distinction to perhaps a Second Life client or these kind of things, there are a wide variety of ways this could be rewritten, because as you say, I think the ideas are relatively fundamental in terms of as you say, the kind of color interface and in transitions and the potential for these cells to be developed to do a variety of things. In terms of the cells that you have actually developed, can you go through them specifically?
Cool. Okay, I can try. Incidentally, I'd certainly these days consider rewriting. If I was starting it again, I'd consider writing the whole thing in Unity, because it seems to be up to the task. One of the big problems when I started, I mean, apart from the fact that there were no engines that were anything like that good, was the odd thing about the creatures that you make in Simergy compared to, say, a first-person shooter game is that you have to be able to plug anything into anything and make composites all the time, and so you need to be able to attach the matrix hierarchies to control the position of everything, and that was one of the things I balked at when it came to trying to change it from managed Direct 3D to XNA, because the XNA's object model is not as flexible as Direct 3D was, and it was very hard to find a way to make it so that you could plug things together to make composites. But as far as I can tell, in Unity you can do that.
Certainly.
You can plug any object into any other object, and it becomes a composite, and it's all managed for you. And then of course, you can script in C# or Boo or JavaScript. Okay, cell types. All right, let's run through some things. Well, I'll go through the ones as I see them, because they're not necessarily in any sensible order.
Yeah, in no particular order.
Bioluminescence. Yeah, that was when I was starting to think about sex. And,
attracting a mate.
Yeah, identifying friend and foe is a pretty important thing for biology. Something I should have pointed out, I guess, is that what I want people to be able to do with this thing is, first of all, build very simple creatures, but then build creatures that can eat those creatures, and then build other creatures that can eat those creatures, and other creatures that can parasitize on some of the others, and so you can build up a complete ecosystem, starting out with simple grazing creatures and moving up to smart creatures that can recognize their prey and trap it in some way, and so on. And sexual reproduction would obviously come fairly well up the scale in terms of complexity, because finding a mate, identifying a mate, navigating towards it, and mating with it is quite a task. So bioluminescence was one of the things that would make that possible. You can have cells that emit pulses of light, but they produce pulses of light in a very narrow band, waveband, and so there are comparable sensors that can pick up that light and be tuned to a particular color light, so the creatures can recognize each other. Sex organs. I did do sex organs. It's a couple of years since I looked at the code, so...
Very good. That was the plan for this evening.
Oh, yes. There's a sex cell that can actually give birth to the creature. So you supply it with the name of the creature that who owns the other half of the DNA, and it constructs a new creature, and it sort of floats out of a hole in it.
Is there a gestation period, or is it an immediate thing?
I think that's controlled by the chemistry.
Okay. As
far as I can see. So you send data into the cell to say, now's the time. Input from plug. Males open labia, females glow. I have no idea what that means.
Very good.
I'm sure females glow and males sweat.
Okay.
Joints. Obviously, joints are pretty important. So that's an angular joint with a muscle or a pair of muscles in it, and so you can control the force and what class of joint it is. There are various. Each of these cells can come in subclasses. So there's a class joint, and that one class can support flex joints, contracting joints, expanding joints, and twisting joints. And so the same piece of code just returns different values, behaves in different ways according to circumstances. So there's various kinds of muscles and joints. Spiny suckers. A toothed mouth for sucking energy.
I was going to ask about that, actually. Very good.
that was when I first thought of this. That was what I had in mind, was these creatures sort of float up against each other and suck energy out of each other, and so there will be an energy economy. And the one that got the most energy will obviously get enough energy to reproduce. So this is a little mouth that can, when it touches up against something, can be closed and grab hold of that object. So creatures can fasten onto each other. As a jaw, the same sort of thing. Okay, that's those.
Is there an idea of scales or these kind of things?
Well, the scale was a bit of a difficult thing for me because I call these things cells, but really they're more like organs.
Certainly.
And because there's relatively small numbers of them in each creature, and they're quite large, and they're quite complex in their behaviors. So you have to think of the creatures as being made out of a collection of organs, and in order to be able to see them, they end up being about as big as your submarine. So they're rather large organs. So scale's a bit ambiguous.
Well, I guess you could have a sheet of scales or something like that.
Oh, sorry, that kind of scales. I'm sorry. I thought you meant visual scale.
Oh no, sorry. No. I mean
yeah.
Like scaly skin. Sorry.
Yes, I wanted to have various kinds of protection. I hadn't thought about scales. It's quite difficult because it's not a fluid, flexible creature. It's a tree structure, and so it can articulate at the joints, but it doesn't. The body's not contained inside the skin.
Certainly.
But you can have carapace cells. You can have cells that are like pieces of chitin, like an insect, and strap those around the creature. And all of these things come with a cost. That's something I should have mentioned. That all of these cells consume energy to do what they do. And the way to design the game would be to make sure that things that are really powerful require a heavier energy cost and so on. And obviously, protecting your creature with sheets of chitin should cost you weight. It doesn't cost any energy to have protection, but it should make you heavy. And so then you've got to either live on the bottom or use more energy to keep yourself moving. Because the whole point is to try to build an energy economy so that it takes ingenuity on the user's part to create creatures that are actually self-sustaining and can gain enough energy to reproduce. So everything has to come at a cost. Processor cells, the ones that go in between inputs and outputs, I've got various kinds of oscillators that produce sort of flapping motions. So if you attach an oscillator to a joint and a joint to a flipper, you'll get a bit of the creature that flaps, and you can vary the intensity and the speed of the oscillators by sending chemicals in through the channels. And so there are various oscillators that produce flapping ramp generation, sine waves, square waves, and pulses. Signal modifiers. Oh, leaky integrators. I love leaky integrators. Everything I do has leaky integrators in. So they accumulate values over time, but they accumulate so their internal state rises the more more chemical you inject into them. But they accumulate it linearly and they leak exponentially. So the fuller they get, the faster they leak chemical out again. And so they tend to stabilize at a kind of moving average state. So you can use those for all sorts of things. I mean, that's an example of a really general purpose kind of cell. It's not at all obvious what you would do with one, but they turn out to be incredibly useful, and all sorts of things in biology use leaky integration. Computing surfaces. That was an interesting idea that I started to play with. And it got more and more powerful the more I thought of it. It's basically just a graph. So imagine a sheet, XY sheet, where the z-axis is the the height of the sheet at any point, so it's a surface, and you can put in value on one axis and another value on the other axis as chemicals, and you get back a chemical based on the Z value from the surface. And it turns out you can use those for all sorts of things. One of the key things I wanted to get as a cell type was a servo motor, the ability to put in a signal to say where you want an output to get to, and it has a feedback signal to say where it currently is, and it works out what output to produce in order to bring the two into alignment with each other to end up. So if you attach it to a muscle and the muscle was moving a heavier weight, it would put in more force to get to the point where you told it to get to because of the heavier weight. Or if it hits an obstruction, it would put more energy in. And you can get servo motor behavior out of these little graphs.
Is it a two-dimensional servo, or is it a one-dimensional servo through how it's kind of... I'm seeing it almost like a cushion servo in terms of its raising and lowering, or is it really a two-dimensional servo in terms of the ability to throw the graph in either dimension? Yeah,
no, it's a one-dimensional servo in the sense that it has a single linear output, but the mapping between... So the x-axis would be the desired state of the servo, the y-axis would be the current state of the servo, and the z would tell you what output it was going to produce to get from one to the other. So it's a semi-linear single-axis servo. But by varying the numbers on these sheets, you can create thresholds and things that scale or add or invert or subtract values. So you can do processing on the chemistry. You can even get logical functions and/or an exclusive OR. And waveform generators that produce complex waveforms given a reciprocating wave as one of the inputs or two of the inputs, and even random number generators. So that was quite exciting. I was quite excited by the fact that this very simple cell type that's just a graph, you send it two inputs and it gives you an output, can be reconfigured genetically to produce a wide range of different functions. And I doubt if I've gone through all the possible functions. There's probably a whole bunch of others that someone could think of just by changing the shape of the surface.
Yes.
Latches. So you send in a signal and it gets stored. So it's kind of memory. So a lot of these computational cell types are modeled on the basic building blocks of electronics. So the ability to modify one signal using another and produce amplification or switching is like a transistor. Well, that's pretty useful in biology too. And in digital electronics, there's a bunch of basic elements that are incredibly useful and get used all the time, one of which is the latch, the ability to send in a 1 or 0 and then latch it so that it stays there. So that's the rudiments of memory.
Certainly.
But interestingly, in the Simergy world, you can, a lot of this stuff, there's a kind of halfway house between analog electronics and digital electronics. So a latch needn't necessarily record a 1 or a 0, it might record a 0.7. So there's a kind of electronics that you could define using these cell types that doesn't exist in real electronics. It's sort of halfway between analog and digital. But more digital type things are monostable. So you put in a signal, it triggers an output, and the output stays on for a given length of time and then turns off again. And there's all sorts of uses for a thing like that. Some sensor triggers it, and then it produces some action that might last for a minute or two. Inverters, that's a pretty straightforward thing. So they shouldn't be there, actually, because those surfaces can do inversion. Navigator cell. Now, this is where I'm starting to get a little more towards the Airfix kit, away from the Lego kit. Because a navigator cell sounds a little bit specialized, and it is fairly specialized. Let's see, you give it, it's got 4 inputs, and 2 outputs. The outputs are left and right motor signals, and so they come out the 2 sides on sockets on the sides of the cell, and you could attach muscles to them and maybe flippers or legs or whatever you wanted to propel the creature by, and the task of the cell is to adjust the movements of these flapping objects, adjust the speed of them so that the creature turns in a particular direction. So the main input is the direction you want it to turn, and it will change the intensity of the flapping on one side or the other. But then you can also send in an intensity to say how hard it wants to flap, so how fast it will try to go. Waveform. Yeah, so without the waveform, you'd just produce a signal that was a differential on each side. So you could drive. You might have cells that produce puffs of water, like an octopus or a squid uses, to fly along with, drive along with, and so you just want to produce a differential signal on the 2 sides, controlling how much water is being propelled out of each side. But if you wanted to make a creature that had fins and flapped its way along and swam, then you'd put a waveform in here, and the cell would modify the waveform to make the 2 flippers flap at different amounts. So that's quite a complex cell, and I don't like that kind of thing. The idea was to try and stay away from things like that. But it's such a useful thing to do. And you could, in principle, make it out of a bunch of other cells, comparators and multipliers and stuff, but it'd be so much trouble and use up so much computation for something that almost every creature needs to do that it was worth defining a single cell type for it. And then on the sensory side, we've got an optical flow sensor that measures the relative movement of objects nearby, so the creature can find out if it's moving or if something's moving near it, and how fast. Speed sensor, so that's measuring its own movement. It's got little hairs that get swept back by all of these cells can have animations, and you can control their animations along with the physiology. So in this case, it has little hairs that stick out the sides, and they flow backwards the faster the creature moves, and then in the animation, and then the physiology produces a signal that's proportional to speed. Right, a passive light sensor, that's detecting the bioluminescence first started with. So you could use that for all sorts of things, allowing a creature to recognize a member of its own species, or recognize its prey, or detect the mood of another creature. Color-specific light sensors measures the amount of light of a given color reflected off other creatures. Sonar, obviously proximity detection.
I was going to ask about that specifically, actually, because I think the potential for using multiple different kinds of sensors for different kinds of communication, and certainly to get Dick Gordon on you, in terms of these individual creatures working together to create broader super creatures. When you said latch initially, obviously there's the electronic kind of latch, but is there also potential for interlocking musculature or something like that to kind of create, I don't know, not necessarily ant colonies, but various other kinds of creatures where they have some interlocking for group collaboration or anything like that?
Wow, not so far, but
something to
yeah, it wouldn't be difficult to add that kind of thing. I mean, in terms of physics, it's quite hard to clutch hold of another object and keep the two entrained, especially if you want to do it quite realistically, so they can slip apart and so on. Although if you move to the physics engine, then that would be really quite easy, because you could just attach the two colliders of the two cells that you want to join with a joint temporarily, and the joint has a breaking strain, so it could break apart again. So it's easier now than it was when I started writing this. But yeah, that would be cool. There must be all sorts of stuff you could add. vibration sensors. Because I was thinking, a lot of these creatures are going to swim around, but some of them might just sit on the bottom waiting for something to float over above them and then leap up and grab it and sink back to the bottom and eat it and so on. The great thing about underwater is there's nowhere more bizarre than under the ocean.
Certainly.
In terms of creatures. I think that's about it for the... Oh, and paired sensors. I set up a whole bunch of cell types where the cell had two sensors instead of just the one. So, detect the level of light on both sides, so it's nice and easy to steer using that kind of thing without having to use two different cells and some kind of comparator and plug together whole circuits just to do a simple task. But I think that's about it for the cell types that I actually put in, but I hadn't spent very long doing that because it doesn't take, you could knock up a new cell type in a matter of minutes.
Certainly. So, ideas of genetic consumption, for example, I mean, this is something that seems to be periodically coming through other artificial life simulations. I guess the ideas of reproduction are almost like genetic consumption, but there may be some benefit almost to have virus cells or these kind of things, which may be very simple, but may have means of either genetic manipulation or genetic consumption of what they attack. So
that would be interesting.
Yeah, there's potentials in those areas too. And also, as you describe, a lot of these cells have been very much derived, well, certainly the movement and the speed and these kind of things for an aqueous medium, but I can see as they left the aqueous medium, they could become things like fur and a wide variety of other possibilities. So I guess really what we're doing here is putting this out to initially the artificial life community, but also the broader open source community in terms of folks listening in who are interested in contributing and starting from these building blocks even as described. I mean, I can imagine people looking at the code and deriving simulations from this, because the building blocks, as you've described them, are relatively simple, but certainly in combination can make quite powerful and interesting things. In terms of other simulations, I mean, obviously Jeffrey Ventrella's work, gene pool, we started talking about this, but certainly there are components of Jeffrey Ventrella's gene pool in what you've described, but there's also potential to hybridize, which I think would be really interesting in terms of when gene pool goes open source as well, the potential. And my understanding is the gene pool that Jeffrey has been working with recently is three-dimensional. It's not just the traditional two-dimensional gene pool, so that would provide some interesting things. And if there's a shared overlap, particularly with regards to the base cells, I think yours have a lot more internal communication, perhaps, although I've never seen the source code to gene pool, so I don't know that specifically, but certainly what you're describing seems to give a lot more internal communication, internal processing potential. So there could be some interesting hybrids that come out of this as well.
Yeah, it's and technology is moving on so quickly. It would be nice to start again, really, with a thing like this. Now we explored the idea. Scale is the big problem with all of these things. There's no limit to what you could build out of cells if you could have 100,000 cells, but we just can't compute that much yet. And render it in 3D and animate it and stuff. So I went for this sort of larger organ-sized building blocks, which is a limiting thing. You mentioned fur, but it would be difficult to make fur as a specific thing. You could have cell types that were sort of little carapaces with fur on or something like that. But these creatures tend to be very plankton-like. Because they're basically tree structures made from relatively small numbers of cells. They don't have a body. You mentioned viruses. It's perfectly possible to make single-celled creatures, of course. An organism can contain one cell, and that cell can have as much code in it as you like, and do the whole propulsion and sensing and intelligence bit all by itself. So that makes it nice and easy to make cannon fodder. Simple little creatures that provide the food sources for the larger, more complex composite creatures. So I was planning on putting very simple plankton-like things that just sort of swim towards the light and or swim around at random in the system. You could definitely do viruses and bacteria and that kind of thing.
Certainly. And you mentioned scale and weight, and if you had surface tension as well, there would be potential for almost insect-like creatures that could skate along the surface of the fluid and dive into it, and all these kind of wonderful physics modelling possibilities too.
That would be neat. Yeah. Each cell currently has a mass and a buoyancy plus whatever energy cost. I don't think it has any. I'm not sure whether it has any other basic properties. There must be others. Oh, and a sort of water resistance value.
Certainly. Well, Steve, I think you've given a lot of food for thought and probably enough examples for folks who are listening in who have an interest in open source development and interest in artificial life to get involved. And just to give the URL for folks who are interested, it is currently hosted on SourceForge, so sourceforge.net/projects/Simergy, Simergy is the place to start. And I'm looking actually for project administrators as well. I'm currently the introductory administrator, the person to contact initially, but I think there are a sufficient number of folks in the community, and certainly even through the Biota Conversations mailing list, Peter Newman and one other fellow whose name escapes me expressed an interest enough to be administrators of the project as well. So certainly it's in no way a walled garden. It's looking for as many folks who want to contribute and even administer it early on. Steve, I don't necessarily want to pry this out of you, but I know you are working on both a software and a book project currently. If you don't want to go into details, are the two interconnected or are they divergent works?
They're pretty divergent, yeah. I'm kind of stuck on the book.
Okay.
The book is called Spirit, and I want to talk about structure and how structure has been lost because of physics. That physics is rather obsessed with variables like mass and matter and so on, and has minimized the way things are put together, very much like the Simergy thing. It's not the cells that make the creatures, it's the circuits that make the creatures. And I think a lot of our understanding of science and people's antipathy towards science comes from the fact that structure has been kind of shut out of the equations.
Right. But this isn't the Kaufman argument. This isn't the argument that the element outside of the physics is, what we may agree with religious people as the soul. This is something quite different, isn't it?
Well, I want to try and relate the concept of spirit to the idea of structure, and maybe suggest that some of the things that have hitherto been assumed to be dualistic, require magic from outside the universe, were really only ever the structure of things, and that we used to have an innate respect for the structure of things that's kind of got lost. It goes back to the Greeks and stuff, but that's all a bit complicated. And as I say, I'm stuck on some of the physics at the moment, so that's not really going anywhere. But the game is much more like my Creatures game that I wrote 18 years ago now. I started Creatures. Yeah.
We're all getting much older, unfortunately.
Yeah, but sadly that's true. On the other hand, computers are getting faster and faster. So
well, to a certain extent. I mean, the thing that my Bay Area trip reinforced was that actually, certainly computers aren't getting faster at the rate that they used to get faster, and what seems to be driving contemporary computing is things like Unity. It's which doesn't actually require it doubles every 18 months in terms of speed, but is actually to do with how these things interact. And certainly the movement towards mobile technology, as I guess it's our group, seems to lend itself to questions of interface, actually. This is the point that I made to Jeffrey in particular, is don't just think about, the tradition of screens and mice and keyboards as we have previously. This is really an opportunity for people such as yourself and Jeffrey, who have a very different background in terms of interaction, to start exploring what multiple fingers do. I actually, I haven't played with an iPad until I was in Palo Alto with Jeffrey, picked up my first iPad and started moving all my fingers on it as much as possible. I have an iPad version of Noble Ape I'm working on currently, trying to get a sense of what this interface actually means in a productive sense, because I think it's very different to a screen and a mouse, and the way you can touch it with, multiple fingers and move around it with, different kinds of experiences, particularly also the tilting. I mentioned that to Jeffrey, particularly with these 3D aqueous environments, that if you rotate the device and move the device around like you're looking into the environment, you can actually update for those kind of effects too. So,
and all the creatures float up to one side of the screen.
Well, no. The idea that you're actually looking through a window into an environment which is not in the physical world, but you are describing. And it certainly, in the late 90s when I used to see VR installations, they were demonstrating these kind of things as, multi-$1,000 devices, which typically had very early LCD screens with strange rotating musculature that enabled it to translate into some very shakily rendered graphics. And the beauty with regards to the iPad in particular and these kind of devices is that they have actually been optimized for this fluid kind of movement and the transition of the graphics. So I think they all give different interfaces, and certainly my experience at Apple and Intel was that they were both companies now that would like to be thought of in the kind of cell phone mobile domain, although high-performance computing is still an interest at Apple, it appears, perhaps to follow Ericsson's line of both providing the phones and also the backplanes that translate the phone data, because, of course, that's another important point to all of this. But like I was saying, I think the ideas of interface that probably people such as yourself have been dreaming about, as you describe in the late 70s, the dream idea of the circuit board, well, the ideas of interface now in terms of general movement, and not necessarily processing, but just, as you say, the complexity and detail that one can get into now lends itself to a wide variety of new artificial life simulations. Yeah,
I think this is a good time for that kind of thing. I agree. These new interfaces are very intuitive and touchy-feely, and just require a different kind of psychology to the very IBM-ish, strict world of keyboards and mice. There's a lot of scope for new ways of interacting, particularly with artificial biology, when you can stroke things and cuddle things. And yes. Interact with them differently. So I don't want to probe too much if you don't want to answer any specific questions, but in the fact that this new game is based in Unity, does that mean that you are intending to deliver it on multiple platforms? Yes, well, just by virtue of the fact that I can. Bless them. Because it'll run on Linux and Mac and PC, and if I paid some more money, on iPhone and iPad and Android and what have you. So that's pretty impressive to be able to produce a complex 3D sim and have it that portable. I'm pretty impressed by that. But right at the moment, I'm just enjoying the sheer pleasure of being able to have metallic reflected surfaces and deferred rendering and light mapping and stuff like that just by clicking checkboxes instead of writing hundreds of thousands of lines of code. Certainly. It's a very nice system. I'm really impressed with Unity. I've looked at lots of other game engines in the past, and most of them are half-written, full of bugs, badly documented, and you can't rely on them staying around for very long. But yes, I think the metaphor of the best of open source and proprietary that things like Unity are now providing seems to be very strong. Yeah. Of course, here's me writing a commercial game, but I need some money.
Certainly. Well, Steve, it's unfortunately we don't charge for Biota Live and we don't pay the guests to come on Biota Live, but you certainly give inspiration when you come on. So you've only been on once before, I think, aside from the 3 interviews that I did. I feel because we're in almost constant communication that you've been on more frequently than that. But for the listeners, certainly your last appearance was inspirational for a number, and I'm sure this will also generate a lot of discussion. So thank you very much for the opportunity to chat this evening.
Hey, you're welcome, Tom. Thanks for inviting me on.
We'll need to have you back on, perhaps even with Bob Mottram, to talk about some of the interlinking with robotics and A-Life. Do you still have interest in the robotics community? Is this something that you still...
Yes, I'm still very interested. I mean, I had to stop building my robot. I was building a humanoid up until about a year ago, and I had to stop that. But my apartment here is stuffed full of robots.
Wonderful.
I'm still just as interested as ever. So that would be cool.
Very good. Very good. Well, thank you, Steve, and thanks for folks for listening in. I'm not sure when the next Biota Live will be. I had promised one with regards to language, and as people process some of the talk, some of the SRI talk of a few evenings ago, you'll get the sense that language is another thing that is coming through the artificial life community currently, and certainly changing the way people think about these kind of simulations in a very non-visual and slightly more, I don't know, maybe social sciences sense. And Steve, if you do get to the end of my SRI talk, I'd be really interested in your thoughts on the whole thing, particularly with regards to the kind of historical aspects of artificial life and how we translate that to a very modern world, although you seem to be doing this in your own thinking, writing and programming currently.
Well, that reminds me, I'm supposed to be writing a chapter on the history of artificial life.
Is that
Thank you for reminding me, Tom.
Is that for Britannica or is that for something else?
No, that's for one of Dick's ventures.
Oh, okay. Gosh. Oh, so you're writing in one of his, is it the Origin of Design one?
Yeah, that's the one. You're involved in that as well, aren't you?
Yes, yeah. I've just finished a chapter for the last Dick Gordon book, and apparently there's still another EvoGrid chapter due, and potentially another chapter due, and then yes, I'm writing on the origin of the word design in a wide variety of disciplines and how we can learn from that. So I'm going to get very Wittgensteinian before it ends.
Oh, wow.
Anyway, Steve, it's wonderful chatting with you, like I've said, and yeah, please don't be a stranger. Please feel free to drop in on random calls, and also if we can organise something more formal in the future to get you and maybe Bob Mottram and other roboticists together to talk about linkings of hard and soft artificial life, that'd be wonderful.
That would be fun.
Look forward to talking to you soon. Good night.
Bye, Tom.